Hello guys, in this video I'm gonna continue our matrix transformation topic, but this time I'm gonna reflect on basically the matrix reflection or the vector reflection. So reflection has many cases. So like what we did with the rotation, I'm gonna start with corner cases, like reflection about the x-axis, y-axis, y equal to x, y to minus x. Then we're gonna take in another video probably the general case for any reflection about any line y equal to x. Then we're gonna have some examples. So let's get into that. So like what we did with the rotation, we start by this notion that the identity matrix 1, 0, 0, 1 doesn't do any effect on the vector. Okay, so any vector, if we multiply I by any vector, it will result in the same vector. Okay, it will not be reflected or rotated. It will stay the same place. Okay, but again, the identity matrix has two columns. Okay, so whenever we wanted to reflect about with any condition, we reflect these two columns. Okay, and this will give us the transformation matrix required, or the reflection matrix required to make the transformation. Case number one, for example, number one, reflect the point 1, 1. So we have point, we have a vector 1, 1 about y-axis, about y-axis. The y-axis has always x equal to 0. You might encounter any y-axis or x. Those are the same basically. So we have here our coordinates. Okay, this is the first like vector, first column, or first 1, 0. And this is the second point, second vector, second column, 0, 1. Y-axis, x-axis. So this is basically the y-axis. Why they call it x equal to 0 axis? Because any point on that axis always has 0 x equal to 0 coordinate. Okay, that's why it's called sometimes x equal to 0 axis. Okay, so we're gonna apply the reflection. Okay, and see how to to get the transformation matrix out of that. So we want to reflect around the y-axis. So we're gonna imagine the y-axis as a mirror like that, and just reflect, about this mirror. So the 1, 0 will be basically here. So let's do it with another color, for example. The 1, 0 will be here at -1 and 0. It's a reflection, right? Like a mirror. A point here will be reflected here with the same distance. Okay, but the axis is the coordinates will be -1. It's the same distance, but -1. Okay, and of course 1, 0, 1, this point will be the same. It is on the mirror itself, so it is 0 distance from the mirror, so its reflection will be also 0 distance from the mirror, so it will be the same, right? So this is our conclusion now. The 1, 0 reflected to -1 and 0. And the 0, 1 reflected to itself, 0, 1 again. So the reflection matrix, they call it usually Q, usually call the rotation matrix R, we usually call the reflection matrix Q, at least this is in the book, but you call it whatever, it's fine. 1, -1, 0, and 0, 1. Okay, so 1, 0 becomes the -1 and 0, and 0, 1 still the same. Okay, let's apply that on 1, 1. That's our original question. We want to apply that. We want to reflect 1, 1. Okay, so we're going to do that -1, 0, 0, 1. We're going to multiply it by 1, 1. So let's do the matrix multiplication here. This will give us -1. This will give us 1. Okay, so the 1, 1, the point 1, 1 will be reflected to another point or another location with coordinate -1 and 1. Let's do that. So let's check that basically. So let's first remove that stuff here. that already, that's fine. Okay, so that's our point. Let's do it with orange, for example. This is a point 1, 1. Okay, and it will be reflected to as a point minus 1, 1. This is the point minus 1 and 1. Minus 1 in x, 1 in y. Okay, and that's makes sense, right? So whenever you have a mirror, any point will be just the same point reflected the same distance, right? So same point reflected. But the coordinate will change from 1 to minus 1. That makes sense. Okay, case number 2. Reflect about the x-axis. Reflect, same point again, 1, 1, about x-axis, which sometimes is called y equal to 0, because any point on the x-axis has coordinate y equal to 0. Okay, so let's draw again the axes here. Okay, so now our mirror now on the x-axis, so that's the mirror. So the point 1, 0, it is on the mirror itself. So it is 0 distance from the mirror, so its reflection will be also 0 distance from the mirror. It's basically the same point, right? So 1, 0 will stay the same, 1, 0. How about 0, 1? Let's do it with red. 0, 1 is here. So when it is reflected, it will be here. Okay, so that's basically 0 minus 1. Still 0 on x, because any point on the y-axis has 0 x coordinate, but it's minus 1 now in y. So the 0, 1 is reflected to 0 minus 1. So our Q mat is a reflection matrix. The 1, 0, no change in the first column, but the second column becomes 0 minus 1. Let's now apply that. So we're going to multiply this by our vector 1, 1. Let's see what's going to happen. So 1, 0, 1, 1, this will give us 1, 0, minus 1, 1, 1, this will give us minus 1. So the point 1, 1 reflected to another coordinate 1 minus 1. Let's do that and check geometrically if this is correct or wrong. So the same. Okay, let's do this, for example, with red, that's fine. So that's the point 1, 1. Okay, so basically it will be reflected to another point from same distance from the mirror, which is x-axis. So that point here has same x coordinate, but the y coordinate is minus 1. The minus sign. That's very correct. Okay, number 3. A little bit complicated now. Reflect 1, 1 still about the line y equal to x. Okay, so let's draw first this line. What does this line looks like? Let's now. So again, this is a y-axis, the x-axis, and the y equal to x is this line basically. It's a line that makes 45 degrees with x-axis. Why? Because on that line, any x coordinate equal to the y coordinate. Any point. For example, this point here. It's 1, for example, 1 and 1. This point, of course, it's not so to scale. So this point is 2, 2, and so on. Okay. This point is half and half. Okay. That's why it's equal to y equal to x. So let's see how we can do that. So let's start again by 1, 0. So that's the point 1, 0. Okay. So that's now the mirror here. This is the mirror. Don't get scared. It's easy. That's the mirror. What we're gonna do? Again, we're gonna see what will be the reflected point, okay, on the same distance from the mirror. So if we just lie down like a line here, a perpendicular line, okay, that's basically will represent the perpendicular distance from the point to the mirror. So the reflected point will be actually here, which is 0, 1. So the 1, 0 point reflected to the 0, 1 point. Oh, yeah. So the Q matrix here, the first column is actually 0, 1, not 1, 0. Okay. Let's do now the second one. It will be a little bit messy because basically we're going to do the opposite. It will be exactly the opposite. So the point 0, 1, okay? We want its reflection. So we're going to do the same. Actually, we're going to end up with the same point that we started with, which is 1, 0. So we're going to do like another perpendicular like line, another perpendicular line here. So we're going to end up here, right? So it's basically, the mirror is just tilted. That's what makes like the reflection a little bit like, messy. But, imagine the line is here. So basically any point here will be the same point here, but on the other side. We tilt it will be the same. Okay. So the point 0, 1, I'm sorry, write it above. The point 0, 1 becomes 1, 0. Just switch it. So the Q matrix here is just the identity matrix, but switched columns. Column 1 become 2, column 2 become 1. Okay. So let's apply that. So 0, 1, 1, 0. Let's apply it to 1, 1. Let's see what will be the new location of that point. I know that you expected that, but let's see. So 0, 1, 1 will be basically 1, 1, 0, 1, 1 to be. Oh, it's the same point. And that's actually predictable, because this point 1, 1 is on the mirror. And any point in the mirror should be the same. I mean, if the mirror is like that, horizontal, and the point in here, 0 distance from the mirror, so its reflection is also 0 distance from the mirror. It's the same point. If the mirror is like that, again, the same point. If the mirror is like that, so any point on the mirror should stay the same. Okay, that's what we have here. Okay, number 4. Number 4. Reflect again same point 1, 1 about the line y equal to minus x this time. Okay, minus x. So let's do that. Of course, if you understand the first case, y equal to x, you can understand this easily. Yx. So that's the line y equal to x. Where do you think is the line y equal to minus x this time? Y equal to minus x means that if y is 1, x is minus 1. Okay, and the opposite, So it will be the same. Basically, it will be the opposite one. So it will be this line here. That line. Okay. That line here is y equal to minus x. So, for example, if y is 1, x is minus 1. If y is 1 here, x is minus 1. If y is 2, x is minus 2, and so on. Okay. That's the y equal to minus x line. Now, let's do the reflection. So we have here our points. The 1, 0 point. Okay. So we're gonna again make like a perpendicular line on the mirror. This is our mirror here. Gonna highlight it so you guys know. So that's the perpendicular line. So where is the reflection? Here is the reflection. Basically, it is minus 1. I'm sorry, it is 0 and minus 1. 0 and minus 1. Okay, so 1, 0 reflected to 0 and minus 1. Good, very good. Now the second point, do it with another color, orange for example. Second point is basically 0 and 1. Okay, again, this is the mirror. We're gonna do again like a perpendicular line. Okay, and so the reflection will be in here, 1, 0. So the 0 and 1 goes to, what is this point here? This point is actually -1 and 0. -1 and 0. Okay, good. So the Q matrix here, let's go back to red. The Q matrix is equal to 0, -1, and -1 and 0. Okay, so let's apply it to our vector 1, 1. 0, -1, -1, 0. Our vector is 1, 1. So let's see how this goes. So we multiply, this is -1, this is -1. Okay, so let's now check that. Let's check if this is correct or wrong. So let's first like remove this guy here for clarity. Okay, here is, go back. Let's do it with like this color. So that's 1, 1. Okay, so we apply a perpendicular like line. We extend it the same distance. That distance is equal to that distance here. Okay, so that's the point here, -1 and -1. That's correct. Okay, guys. So that's basically the reflection with some corner cases. Okay, so in the next video, after this video, I'm gonna record another video showing you the reflection with the general case around any line, y equal to mx, whatever the line is. Okay, and once we have the general formula, we're gonna apply like the corner cases here. Okay, and we should of course get the same cues, get the same reflection matrices that we get here before. Okay, guys, thank you very much for watching and see you in another video. Bye.